Hey everybody, Brian Orr here. Thanks for watching. This video is on A2L refrigerants. This is actually a podcast that I did with Jason Abjut from ESCO. He is really in touch with everything that's going on with A2Ls. But the reason why I'm releasing this as a video is I really want everybody to be aware because there was a recent ruling by the EPA. We expected it, but it just came out on HFCs and the phase down, which means that A2Ls are coming. So you need to be aware of what's going on. And that's why we decided to release this podcast as a video on YouTube as well. And as always, just go ahead and follow the links down in the bottom in order to get more information on this. Thanks for watching, and big thanks to Jason and ESCO for helping us out as always. All right, thanks for joining us again on the HVAC School Podcast, Jason.
Thank you for having me.
So it's been a while. We've been trying to find an excuse, or I've been trying to find an excuse to get you back on the podcast. But this is a super important topic. A2Ls, mildly flammable refrigerants. I think that's right. Mildly, is that what it is?
They call it slightly flammable, mildly flammable, lower flammability. Okay. There's a lot of names thrown around out there.
Okay. And it is going to be a big part of our future in the trade, like it or don't. You can complain all you want, but it doesn't matter. It's coming. Right. It's coming down the pike. But before we get into that, I wanted to just quickly have you update us on what you've been up to lately. Obviously, you've been on before. The audience, I'm sure, knows you, but a lot has changed in your life and your responsibilities. So just give us a quick rundown of what you've been working on.
And I'm an industry author. I've been working on the refrigeration air conditioning technology book with Eugene Silverstein. We have the complete HVAC lab manual as well that we've been working on. And then through ESCO, I wrote a new title, Low GWP Refrigerant Safety. There's a certification exam and a book and some online components and things for these new flammable refrigerants. I've been on all these committees, the Safe Refrigerant Transition Task Force with ASHRAE, and in some of the standards and codes committees, which help me, stay on top of where we're going with these refrigerants, what direction, and what types of things we're going to see once they start coming out. So the development of that program took a few years, and it's still ongoing because some of these codes and standards are still in committee. There's still a few that are going to come out this year.
Yeah, so in terms of kind of expertise about not only where things stand today, but where things are going on this topic, Jason is, the guy who wrote the book on the topic and is involved in all of the these kind of regulatory changes, has his finger on the pulse, so to speak. So it's awesome to talk to you about all this. I want to mention before we even move on, though, I put my full stamp of approval on the RACT manual as being the manual that everybody needs to have in their trucks. I mean, quite honestly, if you don't have at least a few in your company library, you need to get them. And then also all of the titles from ESCO are excellent. If you go to escogroup.org, you can find all of those, and they really are great. Is that the best website to give? Is escogroup.org still the best website?
Yep.
Okay, great. Well, I want to get that out of the way.
I appreciate that. Thank you.
Yeah, I want to get that out of the way because that's authentic. It is literally the book that I learned on, speaking about the RACT manual. And then nowadays it's just so much better. I mean, I have the most recent edition, and it's really, really excellent. So thank you for doing that. All right, let's move on from there and talk about A2Ls. We'll start with the basics. What is an A2L?
All right. It's a flammability designation that comes, from ASHRAE Standard 34, where they're tested for flammability. There's 1, 2L, 2, and 3. For a lot of folks, a substance is either gasoline or water. It either lights up or it doesn't, all right? But the reality is there's a big gray area in the middle there where you need all the stars to line up in order for combustion to happen. And 2Ls are that class of refrigerant where we need a really high ignition energy. We need a good accumulation of the gas in a confined space with the right amount of air in order to get ignition. They're tougher to light than the A3s or the A2s. As we move toward low GWP refrigerants, we're going to see as the GWP of a refrigerant comes down, the flammability is going to start going up. We see that with the A3s, the 290 propane and 600A isobutane. They have almost no GWP. They're very low, 6 or 5 or 4, and they're highly flammable. The 2Ls kind of fall in the middle. They have this lower GWP, this threshold, but they start coming up on the flammability side. So they are flammable, but again, under the right circumstances, and it does take multiple things to line up in order to get them to a combustion state.
Yeah, so a lot of us have talked a lot about hydrocarbons, HC refrigerants like R290, which is propane. Excellent refrigerants that we're starting to see in refrigeration that are, quite flammable. Obviously, we all know they are because it's what we cook our steaks on, right? So, so we've talked about that in the past. This is not that. So it
Right.
isn't the same. It is significantly different. And so as people start to see this, they start to see A2Ls come into the marketplace, they're going to have significant concerns about their homes and all this. What's kind of your take on that? Because it's the first thing that jumps into everybody's mind is like, oh my gosh, I'm gonna blow a house up or something like that.
Well, the design standards, the way things are being set up, both on the design side and on the installation side, there are standards that are set up to kind of prevent this from happening, limiting the equipment charge, requiring certain service practices. And if we are following best practices, we can avoid situations like that. These refrigerants are the type that, again, we're going to have what's called RDS, refrigerant detection systems, that are on board to the systems when you buy them. So if there is some sort of leak, the system's going to know to shut itself down, turn on the blower motor to move some air over the evaporator. It doesn't take a whole lot of air movement to get the refrigerant below that flammability limit, a little bit to kind of disperse it, and then we're below the flammability limit. You also have to have a competent ignition source. With 2Ls, the most likely ignition source is an open flame. A lot of the things that we have in our house, like the light switches sparking, those sorts of things, cordless drills, those are not going to ignite A2Ls. They don't have enough ignition energy.
Got it. Yeah, I mean that comes back to the whole. You need a fuel source, you need a heat source, and you need oxygen. And in this case, it's just a little more difficult for all that to come together for combustion.
The likelihood,
A2L,
right, of having all of those together in one space,
becomes less. And so let's talk a little bit about what some of those common A2Ls are going to be that people see, because I think some folks like, well, I've never seen one. I mean, this isn't a refrigerant that I recognize. But what are some of the maybe recognizable A2Ls?
First, let me start by saying they may be new to us, but the rest of the industrialized world has been using these for like a decade. All right, we're one of the last industrialized countries, jumping onto these. Right now, again, the way it looks like it's going to be 454B and R32 are the two that are going to initially lead the pack. There are 6 refrigerants that are SNAP approved for air conditioning subject to use conditions, all A2Ls, but those two seem to be leading the pack at the moment.
In terms of transitions, what are the regulatory transitions that are driving this? So what are some of those dates that we got to watch out for?
All right, so the big one was the AIM Act, and that was signed in 2020, at the end of 2020. And what that is an HFC phase down. That's not a phase out. What we're going to do is, in line with the Kigali Amendment, it reduces the supply of HFCs, the available supply, over the next 10, 15 years. And it starts next year, January 1st, 2022, by 10%. We'll see an inventory reduction of 10% next year. We're going to see in September, the EPA has yet to put out this ruling. They have to put it out by the end of September. And what that's going to be is basically, what is that baseline number we're going to use? 10% of what? What's that final figure? So in 2022, we'll see a 10% reduction. And then in 2024, we'll see an additional 40% reduction.
Oh, wow.
Yeah, so I mean, this is the 2 middle steps are the 2 big steps. There's a 40 and a 70 in there. And it starts next year.
So that means a few things. It sounds like price and availability might be impacted, and we're talking HFCs in air conditioning. We're really talking 410A. I mean, that's the refrigerant we're talking about. And so, what are we going to start seeing from the manufacturing standpoint? When are we going to start seeing A2Ls actually hit the streets with sort of standard, typical air conditioning equipment in the U.S.?
We would say, again, in my opinion, 2023 to 2025 in that area. Simply because, again, in 2024, when that 40% reduction hits, the price of HFCs is going to go through the roof, and manufacturers that are still putting out, again, 410A equipment at that point are going to face significant cost increase for, building them, charging them, and then maintaining them once they're out there in the field. So we already see them. The A2Ls are in your car. 1234YF is in almost every car now. R32, which we brought up, is already in window air conditioning. It's been in window air conditioning since like 2015. And as you mentioned, the A3s are already in refrigeration. Most residential refrigerators have 600A or 290 in them now. So they're all around us already. We just haven't, it hasn't jumped into our area of the industry yet, but it's about to make that jump.
Yeah, and it will be huge when we start to see it in, the residential split market. That's the residential unitary split market is where it's really going to be a huge jump. So let's jump into, what does a technician need to know? I mean, when the time comes, because a lot of this stuff's out of our control anyway, we're just going to get to a point where we've got to be prepared so that when we have to put our hands on this first, R32 piece of equipment, for example, what are some things we need to make sure that we are doing or that we're aware of?
I'm going to tell you this, if you're already employing industry best practices, you're going to see little to no change. If I put an R32 system next to a 410 system, the biggest difference would be the stickers on the side of it. There's some servicing stickers that are on the side that you have to record certain information on, and then there's an ISO flame symbol on there. But the size of the unit and the capacity of the unit, they're almost going to be identical. In the larger commercial market, we'll see some changes. They might relocate some of the electrical components away from the refrigerant circuit and the package systems. But the systems, for the most part, are going to be installed the same. They're going to look the same. We're going to have some updated tools that are rated for use with these types of refrigerants. But for the most part, if you're following best practices, if you're evacuating like you're supposed to, if you do a nitrogen sweep after recovery, you're recovering to begin with, that's a bonus. If you're doing these things already, you're not going to see a big difference when these come out as far as service. You're going to, confined spaces is a confined space, whether it's an A1 or an A2. I'll tell you, during the flammability testing that was done, even though 410 is an A1, in a house fire, it still burns. Right. It is still fuel for a fire. Your windows, which are made of glass, could be a fuel for a fire if it gets hot enough.
Right.
So just because we say A1... doesn't mean that it's, it won't burn. It will burn. Half of 410A is 32, which is a 2L. Having said that, we're doing a lot of the best practices by, pulling the vac, all of these things if you're doing those things, not cutting corners, you're not going to see a big interruption. You might have to take some training as far as, transportation from A to B. What do I have to do with my service vehicle? And that can come down to a local, where some places might require placards or ventilation of the vehicle. But for the most part, things are going to be unchanged there as well. Storage, warehousing, that's going to be a little different. That'll come down to the local fire code officials, what volume you're allowed to store. Do you need sprinklers and ventilation? You're going to need the NFPA signs and things of that nature. But as a technician, again, if you're employing the best practices, you're not going to see a big difference. You might have to go buy some new tools, but a lot of us get excited about doing that anyway.
Just another excuse.
Right.
So one thing that I'm thinking is, okay, you flow nitrogen while you braze, you're pulling a good vacuum, you're recovering your refrigerant, all that sort of thing. What about cases where maybe you have, the existing compressor and accumulator are staying in place and you're making a repair within the condenser of some sort? And maybe you have, some refrigerant that is still, sort of entrained in the oil, and you get a little bit of that, kind of, I don't want to say it's not off-gassing, but whatever, where you kind of get that little bit of continued, and then you attempt to apply a flame to it. Is that something that you'd want to be a little bit more diligent about?
What the standards call for now is a nitrogen sweep before any hot work. So you're going to have to flow nitrogen through there the initial standards were a little confusing to me, as they were like, okay, well, you got to calculate the internal volume of the entire system, and then you're going to have to flow at a rate of X, and then calculate the volume, and this is how long you have to flow nitrogen. Nobody's going to do that. No one's going to sit down and calculate the internal volume of the entire
right,
system.
Of the system, yeah, exactly.
So what we're going to do is flow nitrogen through there, and before the torch work, to hopefully free up any of that entrained refrigerant in the oil. And then if you're flowing while you're brazing, you should hopefully be okay. You shouldn't get that flare out with the displacement of oxygen through the nitrogen.
Yeah. And then also I would guess a good best practice would be just to not unsweat. Essentially just don't unsweat.
Cut them out.
Yeah, cut everything out. Yeah.
Which
can be tricky sometimes. But
a lot of the standards are allowing in some cases for existing line sets, that can be reused. as long as they are the proper diameter, length, they're clean. One of the things that is a stickler, and it's a requirement now, is a striker plate. And that's where it's behind a wall, going through a joist where it can't move in the wall, where it's pinned in there because it runs through wood and of some sort. You're supposed to have a striker plate in the wall so someone can't go to hang a picture there and put a nail through the line set. We've seen pictures all over of nails going through these line sets.
Right.
So if you want to reuse an existing line set, you're going to have to be able to verify or show to the inspector that yes, striker plates are in place.
Yeah, and that may be very tricky in some cases. Yeah, it actually brings up a good point. Like in our market, we run all these, underground line sets, which is kind of an absurd system anyway, which, reduces the likelihood because you're not in a wall or something. But yeah, if you say you're in an apartment complex or multifamily or something like that, and you're wanting to replace a R410A system with R32, that could be pretty challenging, I imagine.
Right, and then obviously the line set has to meet the standards. There's two tests. It has to have a vacuum test and it has to have a pressure test. They for tightness and for obviously one's a leak test and the other the standard defines as for tightness.
Yeah. Are there going to be any? Because I think some people just immediately just think, okay, well this scares me. Are there going to be any other options? I mean, it sounds like with HFCs being phased out, is there going to be anything that's going to be compliant in terms of the EPA regulatory environment that's not going to be an A2L?
There is one product that's undergoing testing. It's a Honeywell product, 466A. There's a couple of manufacturers that have stepped up to try and test it on their equipment. It is an A1. It has a GWP, a low enough GWP. By the way, let me throw this out there. For the residential unitary market, like commercial, the target at the moment for GWP is 750. All right, and anything over that is going to be undesirable, so to speak. And when we're moving forward as a manufacturer, they're going to look for refrigerants that are under that 750 GWP, and 466 is one of them. The other options that are coming out are like CO2. We're seeing a lot more experimentation and testing with CO2 systems. So, yeah, there's some options that are not A2Ls out there, but they're a little bit further off than the aforementioned 32 and 454 systems that are being tested right now.
Right. Yeah, and no matter what you do, there's probably going to be some significant, considerations. Like, for example, you mentioned CO2. Well, it's, at that point, it's a completely different animal. I mean, you're definitely not going to reuse existing line sets if you're going to CO2. So, no matter what you do, you're going to have to change some of our practices in terms of what we sell and some of the
labor involved, right?
The labor involved, yeah, exactly. It's just going to be part of it, and gonna have to price it in. That's how that works.
We're going to roll with it.
Yeah, that's what we got to do, right? So you mentioned the tools. I wanted to give, because you had mentioned that you just recently had a webinar with Bill Spohn from TruTech Tools.
Actually, it was with AHRI.
Oh, it was with AHRI.
Yes.
Okay, all right.
Bill Spohn is the one that took the information and ran with it.
Got it. Okay, as he usually
he took
does.
it to the next step, right?
Yeah. Okay, great. So yeah, he actually put up a page on his site that shows some of the A2L allowable tools that you can use with A2Ls. And so if you go to truetechTools.com/A2L-compatible-tools, you can also just go to his site and find it there as well. If you just go to the cooling section, so it's under the cooling tab where you would find the A2L compatible tools, that will show you some of those, because I know a lot of techs are going to immediately think about that. Are there any other best practices, things to kind of watch out for, things that maybe could change with this? Is most of this kind of written in stone? Do you think there's any possibility that any of it might change along the way before some of these dates hit?
One of the things I would throw out there is left-handed threads. Just get used to them.
Okay.
We're going to see some manufacturers with their flammable products, whether it's a 2L, or a 3, if it's flammable, they like to use a left-handed thread on there. There's no consensus yet, so right now at the moment, if it were to come out tomorrow, we might see some at right-handed, some at left-handed. Obviously, because I just said left-handed thread, somebody is already selling on Amazon an adapter. It just happened as we were speaking. There's already an adapter.
Right.
So that's something to be aware of, something that's going to be a little different. And the other thing I want to bring up, it doesn't necessarily appear in the standards yet. As of yet, it's a best practice, but when we're driving down the street and we see the utility companies and they're out doing their work with their vans and things, they cone off their work area. And it's not something that kind of carries over into our industry for some reason. And I would implore technicians, when you're working with these types of, refrigerants, set yourself up a secure area that is free from ignition sources, and don't let anyone enter that area, including the homeowner who might be smoking a cigarette and just brought in a possible ignition source for the refrigerant that you're working on. So even though, again, it's not 100% required in the standards, I would implore you to, all the other trades are doing it, all the other industries are doing it, let's do it ourselves. And it's something that can help us be a little safer on that.
Yeah, I would also anticipate that once a lot of state and local governments sort of get aware of this, there's probably going to be a lot more on the hot work permit side. There's probably going to be a lot more fire watch requirements, all that sort of stuff. And again, you don't know. We're just going to have to wait and see. But that's something to watch out for. And it's especially important in the midst of a transition. So this is kind of a tip for contractors in general. When you're in the midst of a transition, you don't want to price out a job thinking that things are going to stay the same and then have it get accepted and then have it change in the middle. Sometimes there's this buffer space, especially on larger projects. So really start to think about this and prepare for it so you don't get stuck. The last thing I want to see is a contractor getting stuck, not realizing that they had to have the additional labor associated with this stuff, and then maybe not being as profitable or losing money on a project.
But from a residential, light commercial, unitary, split system, package system, heat pump, air conditioning market, we're not going to see a whole big difference. You'll see more things inside. Some of the electrical components are going to be intrinsically safe. And if you're going to test those, you have to open them up and test them. You got to make sure that you reseal them so that they're still intrinsically safe when you put them back. We're going to see RDS on board, which is sensors that will shut the unit down when it sniffs a leak, or if it senses a rapid drop in pressure that could be a leak, it will turn the unit down. In commercial systems, we're going to see things like a pump down, where if it determines there's a leak, it will pump the refrigerant outside. It will isolate with solenoids. It'll activate mechanical ventilation. Again, this is all going to be native or resident in the equipment when you buy it already. So for those of you thinking, I am not going to install it, you don't have to install any of it. It's going to be a series of dip switches that you set up based on how much refrigerant you charged in the system, how much cubic volume is the space that you installed it in, those sorts of things. And you move the little dip switches and you have a nice day. Yeah. I mean, like usual, it always sounds worse than it really is. I mean, I shouldn't say that. Sometimes things are worse than they sound. But in terms of the regulatory stuff, we've gone through this so many times now, right.
and there's always the doomsday stories. I remember when 410A first started hitting the market, people were saying compressors were going to blow up and all this stuff, and that just never happened. So
I will say this: the transition to 410A, in my opinion, was a bigger deal than the transition to 2Ls, because when we transitioned to 410A, we were introduced to POE oil and how hygroscopic that was, and then the higher pressure rating. Again, we had to have tools and things of that nature. So again, there were multiple areas there that we had to be aware of. We're already now used to high pressure. We're already used to the POE oil. So all we have with this transition is a slightly higher flammability.
Yeah, for sure. And like you mentioned, things like storage and all that is probably going to be a bigger thing to deal with for the contractor than even maybe service practices. Again, assuming that you're following proper service practices. And we talked about sweeping nitrogen as an example. I mean, I would say the majority of technicians in our industry, sadly, still don't do that. And so we've got to go ahead and just take that seriously now. There are even, whole shops that don't recover, like you alluded to earlier. So that's the kind of stuff that we got to get a handle on, because when you start to deal with any level of flammability, now it's really not a joke. I mean, it never was a joke, but it's even more so kind of added on top of that. So just to be clear, I want to make sure that nobody's hearing the wrong thing here. Just because something has a lower GWP, a lower global warming potential, that does not mean now that it can be vented. Because I think a lot of people confuse it. They confuse it with naturals, and so because with naturals like propane, those can be vented because they have a very, very low rating. But in this case, these cannot be vented; these have to be recovered.
I will point out that 1234YF, which is the refrigerant we're seeing in the automobiles, has probably one of the lowest GWPs. It's less than 1, and we still recover it. So It's just one of those things. These A2Ls for the most part are all still covered by 608. We have to recover them. They can't be vented.
Right.
We want to return them for reclamation, that sort of thing.
Yeah.
And retrofitting, that's a no-no.
Right. Oh, okay. Yeah. Cover that quickly.
If I don't even know if I should tell this story, but this guy chimed in saying, "Well, listen, if it's an R32 unit, when we go switch to R32, can I just charge the 410A unit with R32 because half of 410 is 32? I just put half the charge." So that's the logic that scares me. Okay,
right,
because
okay,
there are
right. Got it. Okay.
These refrigerants are approved for use in new systems only, where mitigation has been designed into. There's a standard UL2-40 that all the equipment is tested to, and in that standard is where we have all of the safety criteria that need to be addressed by the manufacturer before they're allowed to release this to the public. So we'll see intrinsically safe electrical components, refrigerant detection systems, sensors, those sorts of things that are designed to make this unit as safe as possible. If you're going to try and retrofit an existing system to a mildly flammable or slightly flammable refrigerant, it lacks all of those. Right. All right, there's no safeties in there. There's no intrinsically safe electrical components, no ventilation, no anything. Basically, you're creating your own unit. So again, these refrigerants are approved for use in new systems only that are designed to work with them.
Yep. No retrofitting to R32 once you find out that it's a good refrigerant, which you will. I mean, I think in some ways, 32 is actually a superior refrigerant, a pure refrigerant, than even 410A is.
The thermal properties, right? Yeah. So what we're going to see is because those types of things, we're going to see smaller charges because we can move the same amount of heat with a smaller volume of refrigerant. Yeah,
and in some cases, potentially slightly better efficiencies as well.
Yep.
Yeah. So so there definitely is some things to like about it, and that one nice thing is with these refrigerants, the pressures are going to be very similar to what we're used to seeing. Right. We're not going to see a significant change there. Not that that really matters anyway. And the other nice thing with R32 specifically is that since R32 is a single component refrigerant,
right.
You're not going to see glide. When you go to some of the other options, that's where you see significant glide.
Right. 454B doesn't have a real high glide. It's pretty low. I think it's like 2 degrees or something along those lines.
Yeah.
And it's around the same pressure as 410A is now, maybe a slightly lower. But again, we're used to this already because, believe it or not, I think 410A came out, I want to say it was 1990. Yeah. So, I mean, it's been around for a long time. So we're used to these pressures and we're used to the POE oil already.
Yeah. And like you mentioned, that was a huge change. In fact, just to kind of pay homage to the reason why it was such a big change and continues to cause so much conflict. When we were using mineral oil, we could get away with a lot of stuff. Mineral oil doesn't have the solvent properties that POE has. Mineral oil handles moisture much better than POE does. And so in both of those cases, people weren't pulling as good of vacuums and they weren't flowing nitrogen. And it still wasn't good. It still hurt equipment, but you got away with it to a degree that you don't get away with it anymore. And that continues to be the case even for further reasons. Not that you're going to have combustion inside of a system with just a little bit of oxygen in it, but for obvious reasons. When you have something that is mildly flammable, you want to keep oxygen, air, water vapor out of there. You don't want it in there.
My other primary concern would be the sludge or the acids that can result from that moisture. And a lot of these mini splits where we have EEVs that have these tiny, tiny openings and there are check valves and flow valves all through these complex systems. You've got this super, super expensive system. You spent all of this time installing it properly and just a little bit of moisture in there causes some kind of an issue and all of a sudden the whole system is down.
Yeah. Was it reactions and all that stuff. And that's also, we don't always know how things are going to change. As we've seen before, it wasn't necessarily even the refrigerants or the oil. Sometimes it's additives that react with moisture or react with whatever's in the system that's not supposed to be there. And then that causes these unexpected results. And so we really just need to keep all the air, all the water out of the system.
Best practices,
and that solves
right?
a lot of problems, right? And by flowing nitrogen while brazing, it keeps that cupric oxide from building inside the line. So it's.
But we should have been doing that back with R22. You know what I mean? That's something that's just following us no matter how far we go. That's gonna I'll tell you, if someone says, well, "How do you endorse this?" Listen, I'm not here endorsing any refrigerant. If they told me tomorrow that Diet Pepsi is the new refrigerant, I'm going to learn how it works, and I'm going to teach others how to use it. That's my job. That's what I do. immerse myself into it. I learn as much as I can, and then I communicate it to others. That nitrogen that you're speaking of, flowing nitrogen, has followed us through the entirety of this. I mean, it wasn't as popular back in the day, but it should have been. We should have made a bigger deal of it back then.
Yeah.
And whatever the next transition is going to be, it's going to follow us there too.
Yep, exactly. All really, really good points. For people who want to find out more about this topic and want to kind of stay in front of it so that way they are not surprised, what are some of the best resources that they can pay attention to? I mean, in addition to, obviously, your book at
I was going to say,
ESCO
we have a training program and a book that you can get at the ESCO website. It's the low GWP refrigerant safety book. But as I mentioned at the beginning, I'm one of the members of the AHRAE Safe Refrigerant Transition Task Force. It's the SRTTF. And there's a whole group of people from everywhere, all industry manufacturers, OEMs, refrigerant manufacturers, equipment, tools. There's a lot of people on this project, and we're subdivided into subcommittees to address different areas of the the transition. And all of the information that's generated is dumped on this site and available to anybody. So if you go to this, to the SRTT, just put SRTTF in Google, and it's going to come up AHRI. Google responsibly. And on that page, you're going to see, you can get on the webinars that we've done. We've done 10, 12 webinars already. There's a newsletter you can sign up for. And there's chapters. And in these individual chapters, you can see information that comes right from the horse's mouth. These things are done by the manufacturers, by the OEMs, by the refrigerant manufacturers. And it's all, again, available to anybody that wants to go on and read. If you're looking for something to occupy your time on a job site while the vacuum runs, you can go on there and read one of these chapters or watch a webinar or the newsletter. As there are new developments with this AIM Act, the newsletter is the best place to, because the AHRI staff put out the newsletter monthly, and all of the latest updates with standards, codes, and the AIM Act are all in that newsletter.
Yeah, so it's I just looked it up because I Googled responsibly. It's ahrinet.org/safe refrigerant, ahrinet.org/safe refrigerant. And if you look to the right there, it gives you a place to subscribe to the news. So that way you'll receive it as things change. And yeah, sure enough, it's got all these chapters in here that just kind of explain everything. So yeah, it looks like a great resource.
There's also a little tab on the left side. It says Ask the Experts. So if there's a question when you're going through the material and something pops out that's not answered in that material, you can submit a question and they'll direct it to the right person that answers it. If it's a compressor question, it'll go to the compressor manufacturer. If it's a refrigerant question, we'll send it to and they'll provide a response, and we'll either post it, email it, or put it in a newsletter.
Yeah, very good, very good. All right, what else do we need to cover? Anything else we need to hit on here?
I think we got a lot of it. I just want to reiterate the flammability thing, because that's on everybody's mind that's preying on. I mean, I see the comments. I listen to the conversations. This is not as you said, doomsday. We're going to blow ourselves up, and chucking a truck is going to make a bad name for us. If you're cutting corners, if you're doing things that are shady, let's just put it that way, you're probably going to have some issues. You're probably going to have problems. But if you're doing things the right way, you're not going to be upended. This isn't going to upset the natural flow of things. You might have to go and read some things. And I know once these systems start hitting the market, the OEMs are going to have classes on their particular equipment. So they'll say, listen, this is what we put in there to sense a leak. This is how we shut the unit down. This is how we mitigate it. And here's how you mess with the settings for that. On an installation side, I don't think there's anything extra we have to do. In my opinion, we might have to run an additional piece of thermostat wire from the evaporator out to the condenser. And I think on an installation, that's about it. I mean, otherwise, it's the same install as the one you just did this morning.
Yeah, exactly. And I think, once we deal with the, kind of figure out what the OEMs are putting in as far as refrigerant sensing, learning about how that works is going to matter. That's going to be specific to the equipment that you're working on. And
I will point out there was an awesome webinar that AHRI did. It's an RDS, and it took 5 of those manufacturers. They all got together, and they came on and each one explained what their sensor does and what alerts it and how often these things test themselves like every 10 seconds internally, and when should they be replaced, and what would set them off, and where should I put them. It was a really, really good webinar on these sensors. It's called RDS 101, and if you go to that same website and go down to the webinars, it's on there. So it's some really cool information in there.
Awesome. All right, great. Yeah, it's a lot to learn, a lot to stay up on. But like you mentioned, not going to be that big of a deal as long as you're doing what you're supposed to do, and you're at least paying some measure of attention. Make sure that when your particular OEM begins to offer this equipment, that you take the training, so that way you know the specifics of the piece of equipment that you're working on. I'm sure most of them are going to have certifications and that sort of thing that they're gonna have as part of it, probably.
I'll throw this out there. There's a lot of programs out there already. All right, general training, safety training on how to handle A2Ls, how to in line with the current standards. There's standards and codes that are already updated, that already allow for the use of A2Ls. ACA has training, ESCO has training, FSRI, which is the fire service, they have flammable refrigerant training on their website. And then ESCO does have a safety certification exam. It's a closed book exam. And there's there's an exam on the ACA one as well. There's a lot of training that's already out there. Don't wait until the last minute and you're trying to cram through it and figure out, you're sitting in the homeowner's backyard reading this book to figure out how an A2L should be handled. That's too late.
Yeah, for sure. And again, escogroup.org is the place to go to get some of those classes, as well as Jason's excellent book. So go take a look at that. And yeah, Jason, thank you so much for being a steward of the trade and making sure that, it's just great to have somebody keeping an eye out for us. I learned so many things from you. You've brought so many things to my attention over the years, sometimes even sometimes I get the cell phone call like, "Hey, Brian, idiot, you're gonna screw something up. Stop saying that." It's like, "Hey, thanks. I appreciate that." So it's good to have somebody watching out, and I really do appreciate it.
I don't know if you want to let them know I plan on coming.
Oh, yeah, to the symposium. Yeah,
yes.
Yeah, we need to mention that. So, yeah, Jason is going to be at the symposium. This is a good opportunity for me to plug the symposium, which I always forget to do. hvacrschool.com/symposium for you to either physically attend. If you can't do that, then we'll also have the session live streamed and then available afterwards as well. Jason's session as well as all of them. But yeah, we're super excited to have Jason. This is his first time at the symposium. We had to pay the big bucks in order to get him, but we're thankful. Just kidding. No, I was very thankful that Jason's coming down. It's gonna be a lot of fun. So if you want to join us in person, it'll be a good time. Bert will be there, so it'll be fun. You always know it'll be fun if he's around. So.
He's contagious. He is. When
really
he smiles, I have to. I don't even know what's going on, but when he smiles, I start laughing too.
Yeah.
So.
No, he probably doesn't know what's going on either. That's probably why he's smiling. You know. Anyway, all right, Jason. I appreciate you, buddy.
No problem, Mike. Thanks for having me.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.